Okay, so this is a tutorial on how to vote using the Cypher Poll protocol. It's in a rather experimental stage, and one thing that I want to point out before we start is that I have hard-coded the password for the GPG key to be 1234. So in production you would not want that, but for now we're just gonna assume that the password is always gonna be 1234, and that should be in crypto source GPG. Yeah, you could change this to your own password and it would work just fine, but for now I'm gonna assume that it's gonna be 1234. Okay, then let's dive right in. We have to first create a new access token. How to get here is documented in the README. You can just click this link and you will be forwarded to this page. And we want to create a token that has read access to GPG keys. So I'll just have to look for that option. Here, read GPG key. This is exactly what we want, so we're just going to generate a token. We'll call it a Cypher Poll test. Cypher Poll test and generate. Alright, now that we have this token, we're going to place it in our path. So I'm going to modify my bash.rc, and I'll override this token to be the new access token. You can specify this variable however you like, it just has to be available in path. Now I'm going to source my bash.rc. Alright, and now that we've done this, we need to generate a new GPG key and associate it with our GitHub account. So I'm going to navigate into resources, in test, and remove the existing keys. Now there's documentation in the README on how to do this. I'll just copy this command, create an elliptic curve key with the default curve, default, yes, test, and some comment. That's okay. Passphrase, as I mentioned earlier, must be 1234, or you'll have to change the code, which is not too hard to do either. We'll take the weak password and did this work? Let's check. GPG list keys. Oh, I think that's the terminal being buggy. Yeah, here we go. This is our new key. So we want to export this. And how we're going to export this is we're going to copy this command, paste it in here. We'll change the name to just key.sec.asc, and ASC means it's an ASIC format. So we want to copy the identifier, paste it here, and enter our passphrase. And now we have the key the secret key written as an ASIC file, and we'll do the same for the public key. So yeah, I accidentally pasted it pub here. We'll also rename that to just key.asc, and we will again use the same identifier to export the public key. All right. Next up, we want to cat our key, our public key, and copy it. This is the public key, so key.asc is the public key. And we're gonna add this to our GitHub account in the GPG key section. Oop, that didn't work. Copy again, paste, and call it Cypher Poll test key. Add the GPG key, nice, now it's associated with our account. And that's basically all we need to do, because now we can run the Cypher Poll service locally, cargo run p service, and navigate to scripts and run the register.sh script. That worked. I'm accidentally printing like a response here, but I'll remove that. You will probably not see this. It's printing the associated keys, but that's fine. So next up, we want to run the vote command, and it's gonna generate a zero knowledge proof. So this is gonna take some time, but then hopefully we're gonna see an anonymous vote registered here on this side. Okay. What happened in the background when we registered is that it checked that the key that we used to sign our message actually exists and is associated with the GitHub account that we claimed. So if you want to understand more how this works, you can go read the code, and the scripts in particular, they basically have all the parameters that you need to register a vote. We have this -- data flag here that is a random seed. In production, this will be generated automatically, locally, but for now, you will have to pass it whenever you run the register command. This is used to derive your nullifier that you then use to redeem your vote when you run the vote command. Yeah, all your voting information is kept secret until you redeem it, and then you will just redeem a nullifier and it still can't be linked back to your GitHub identity. So the more people use this protocol, the more anonymous it becomes, as you have a delay in registration and redeeming a vote, similar to how transactions work on Tornado Cash. And that worked. We voted for time load, and it also printed the election state, and that's exactly what we wanted to see.